We're thrilled to introduce DYBLI-ML, an extension to Monedas, your go-to platform for smart device management and integration. Now you can take your operations a step further by effortlessly creating and launching AI jobs. Our primary aim was to simplify data annotation and enable the use of curated models for real-time fault detection in industrial systems. Let's dive into a practical example of how our system operates with some open-source data. Imagine the task of building a predictive maintenance model for various types of failure states. In our system, we have motors which have been identified to run at different failure states. Now let's take a closer look at our ML DevOps platform, DYBLI-ML. Here you'll find two options: data uploaded by users to the object store, or data streaming from devices connected to our platform. To analyze these distinct data sources, we've created separate branches on GitHub, one for reading file-based data and another for direct database queries using user credentials. Once you've selected your data source, it's time to configure other AI job parameters. You can specify the number of epochs and estimate the required resources for running the model, considering the data size impact on memory usage. We have also added support for GPU-based jobs with a limit of 4 concurrent GPU. Should your job demand more GPU, we're ready to address that scenario on a case-to-case basis. Note that users can run multiple jobs in parallel without the need to wait for one job to finish. With your job settings in place, it's time to launch and monitor its progress, all while keeping an eye on key metrics. Now we see how the job is running, and we can look at several tabs which include the AI job information, configuration, and output, which are tied to the model created at the end of AI job. We also created an API where users can stream certain ML metrics such as accuracy and loss. Admins can view the log of the job to ensure that the AI jobs are properly configured. The purpose of DYBLI-ML is for experts to create and manage AI jobs, which later industrial users can simply launch or rerun for inference tasks without needing to understand the complexity of data retrieval and data transformations. After training is complete, you can export the model. And here's a bonus: you can even import your own models. You have the option to share your model with the public, offering future users a head start for their AI endeavors. They can use it as a baseline and fine-tune it to their specific needs. A crucial aspect of the DYBLI-ML project is its focus on scalability and device agnosticism. We can integrate devices using LoRaWAN, but also directly using Wi-Fi. We have integrated a wide range of sensors, from vibration sensors measuring data at 5,000 Hz to temperature sensors. Here we show the sensors that we have located at our industrial site, and you can see that it is measuring data for 3 axes. Then we have our temperature sensors, where we show that our platform can not only visualize the time series data, but store a wide variety of device metrics. Now that we have a model, let's put it to work. In the inference section, you'll see how our models excel at fault detection in electric motors at an industrial site. Our system's real-world application demonstrates that DYBLI-ML can monitor and predict potential failures in large industrial production lines. By spotting issues early, industrial users can minimize downtime, boost operational efficiency, and enhance overall productivity. Thanks to integration into the KYKLOS 4.0 marketplace, industrial users can swiftly leverage our system for any time series data application. DYBLI-ML also introduces a user-friendly ML operations (MLOps) solution tailored for the industrial sector. This accessible approach simplifies the adoption of machine learning technologies within the KYKLOS 4.0 ecosystem, encouraging more participants to explore ML for their manufacturing needs. This diversity enriches the ecosystem with a wide range of applications and solutions. By enabling participants to share ML models among themselves, DYBLI-ML also promotes a circular exchange of trained models. This collaborative approach reduces redundancy and saves time and resources for individual participants who would otherwise need to set up and train their own independent systems. The ability to share models fosters a sense of community and collaboration within the ecosystem, strengthening its overall cohesion. Additionally, DYBLI-ML optimized fault detection and predictive maintenance contribute to the KYKLOS 4.0's mission of optimal energy and material consumption. By identifying potential issues and inefficiencies, participants can take proactive measures to minimize energy usage and material wastage in manufacturing processes. This eco-friendly approach aligns with the broader objective of sustainability and environmental responsibility. We also seamlessly integrate with third-party tools, for example KYKLOS 4.0 Maintenance Scheduler. Here we use our predictive results to generate maintenance tasks for technicians who do not need to understand or manage the ML ops system. Not only do we allow for flexible third-party integrations, but also we made our ML ops system to not just able to predict failures, but predict for a diverse range of results. Therefore, it makes it easier to not only keep track of manufacturing failures for predictive maintenance, but also other circular economic metrics like optimizing the manufacturing line where too much energy is consumed. The integration of the DYBLI-ML project into the KYKLOS 4.0 ecosystem opens the door to an array of additional use cases, further enhancing our system's capabilities. DYBLI-ML showcases the benefits of a self-managed MLOps platform, making data labeling and model curation easy. This, in turn, drives the creation of diverse models and input data, making our system even more appealing to industrial users who require management and analysis of a wide range of data streams. Moreover, the incorporation of DYBLI-ML into the KYKLOS 4.0 marketplace provides tangible evidence of the potential advantages of advanced AI and ML technologies, without the complexities of integration. The sharing of information and data in a circular manner becomes invaluable for advancing a more sustainable, efficient, and innovative manufacturing environment. Thanks to KYKLOS 4.0 for giving us the opportunity to build DYBLI-ML, a ML ops solution for the industry. Get ready to embark on a journey towards a smarter and more circular future with Colombo Link.